In the scorching heat of the Mojave Desert in California or the arid plains of Arizona lies a spectacle that is both tragic and magnificent. It is a parking lot for giants. Miles of red sand are covered with the white, sun-bleached skeletons of Boeing 747s, Airbus A380s, and McDonnell Douglas jets. This is the airplane Boneyard. Why here? Because the dry desert air and low humidity prevent rust and corrosion, preserving these aluminum titans until their final fate is decided. An airplane is a machine built to defy gravity, designed to travel millions of miles at 600 miles per hour. But like all machines, they have an expiration date. When the cost of maintenance exceeds the profit they generate, they are flown here for the last time. The pilot lands on the runway, shuts down the engines, and walks away. The plane will never fly again. It has entered the deconstruction zone. Recycling an airplane is not like crushing a car. It is a complex forensic surgery. An airplane is composed of over 300,000 individual parts, many of which are worth more than gold by weight. The first step is the safing process. A team of hazardous materials specialists boards the aircraft. An airplane is full of toxic fluids, jet fuel, hydraulic fluid, skydrol, antifreeze, and sometimes even radioactive materials like depleted uranium used in counterweights on older jets. These must be drained and disposed of with extreme care to prevent environmental disaster. Explosive squibs in the fire suppression systems and ejection seats, if military, are disarmed. Once the plane is safe, the vultures descend. The most valuable parts are harvested first, the engines. A jet engine, like a Rolls-Royce Trent or a General Electric GE90, is a masterpiece of engineering containing titanium, Inconel, and single crystal turbine blades. Even on a scrapped plane, a working engine can be worth $2 million to $10 million. Giant cranes carefully unbolt these massive pods from the wings. They are lowered, wrapped in protective foil, and shipped to refurbishment centers to fly on other aircraft. Next comes the avionics harvest. The cockpit is stripped. The flight computers, navigation systems, and black boxes are removed. These small metal boxes contain rare earth metals and proprietary technology that retains immense resale value in the aviation aftermarket. Then the interior crew moves in. They work at a feverish pace, stripping out hundreds of passenger seats, miles of copper wiring, overhead bins, and galleys. The seats are often sold to aviation enthusiasts or upcycled into luxury furniture. The miles of copper wire hidden in the ceiling and floor are pulled out by winches destined for the copper smelter. What remains is the hulk, the empty aluminum shell of the fuselage. But even this shell is complex. It is not just aluminum, it is a high-tech alloy series like 2024 and 7575 aluminum mixed with carbon fiber composites, titanium rivets, and steel landing gear. Separating these materials is the biggest challenge. The landing gear, massive struts made of ultra-high strength steel, is removed. These are often refurbished, as landing gear has a mandatory replacement cycle. The windows are popped out, the plastic is recycled. The insulation blankets, often yellow and dusty, are ripped out. Now the plane looks like a picked-over carcass, a hollow metal tube sitting on wooden blocks in the desert dust. It is a ghostly sight, but the final violent stage of its life cycle is about to begin. The sheer scale of waste is overwhelming, but the efficiency of recovery is a testament to the value of aerospace materials. With the valuable organs removed, the skeleton faces the executioner. Enter the excavator shear. This is a massive piece of heavy machinery, a tracked excavator equipped with a hydraulic claw that looks like the jaws of a T-Rex. This claw, made of hardened steel, can exert thousands of pounds of cutting pressure. The operator drives up to the Boeing 747. With a deafening screech of tearing metal, the shear bites into the fuselage. It cuts through the aircraft skin as if it were paper. The sound is visceral, a mix of grinding, snapping, and the groan of structural metal giving way. The operator is skilled. He doesn't just smash, he sorts. He deftly grabs the tail section, twists it, and rips it free. He separates the wings, which are full of complex spars and ribs, from the main body. The cockpit, the face of the plane, is often sheared off in one piece, sometimes preserved for flight simulators or museums. The rest of the fuselage is chopped into manageable chunks, roughly the size of a small car. These jagged pieces of aluminum are loaded onto dump trucks and driven to the on-site shredder. The shredder is a beast of a machine. A conveyor belt feeds the aircraft sections into a chamber filled with rotating hammers. These hammers spin at 500 RPM, pulverizing the aerospace-grade aluminum into confetti. The violence inside the shredder releases immense heat and dust. The output is a stream of fist-sized metal shards. But this stream is dirty. It contains steel rivets, titanium bolts, and stray bits of plastic. It must be purified. The shards pass under a massive magnetic drum. The magnets snatch the steel and iron rivets out of the stream, separating the ferrous from the non-ferrous metals. The remaining aluminum and titanium mix goes through an eddy current separator, or heavy media plant. Using liquid density flotation or magnetic fields, the heavier titanium is separated from the lighter aluminum. Titanium is incredibly valuable, used in medical implants and high-performance cars. The purified aluminum shards, now known as twitch or zorba in the scrap trade, are melted down in massive furnaces. The paint, labels, and protective coatings burn off, creating a thick slag that is skimmed away. What remains is pure, molten aluminum. This liquid metal is cast into giant ingots or rolled into sheets. There is a poetic irony in this process. The aluminum from a retired Boeing 747, which once flew kings and presidents across oceans at 40,000 feet, might end up being recycled into a soda can, a window frame, or a bicycle. An airplane is 90% recyclable by weight. In the past, planes were left to rot or sunk into the ocean as artificial reefs. Today, the economic value of the metal ensures that almost nothing is wasted. The graveyard of giants is actually a gold mine. However, the future poses a problem. Modern planes, like the Boeing 787 Dreamliner, are made of carbon fiber reinforced polymer, or composites, not aluminum. Carbon fiber is incredibly strong and light, but notoriously difficult to recycle. You cannot melt it down like metal. As these new plastic planes reach their retirement age, the industry faces a crisis. How do you recycle a plane that doesn't melt? Scientists are currently developing methods to grind up the carbon fiber or use chemical solvents to reclaim the fibers. But for now, the aluminum birds of the 20th century remain the kings of the recycling world. As the sun sets over the Boneyard, the silhouettes of broken wings and severed tails stand as a monument to the golden age of aviation, waiting for the shear to turn them into something new.